Hello students, today we will be doing a very interesting topic which is very important for the exam point of view, which is equipotential surface. Okay, equipotential surface. Equi means what? Equal, right? Equal potential surface. Okay. Now, to begin with, suppose let me consider a point charge. Okay, point charge. Let me consider. Okay. Now, what is the expression of potential due to a point charge? That is kq by r. Right or not? Right. Now, let's say at some distance, say r. Okay. At this point, what is the potential? V, right? At the same distance, because in a three-dimensional space, what? At the same distance r, what is the potential? V. At the same distance r, what is the potential? Same, right? At the same distance r, what is the potential? Same, right? Now in the three-dimensional space, if I'm going to join these same potential points in three-dimension space, what type of surface it will come? This surface, right? Student, looks very bad. Let me make it again. Okay. Suppose this is Q, right? Now at the distance of R, right? Okay, the same distance R. Okay, then at all the surfaces, what? The potential will be same, right? Isn't it? So this surface, let me name the surface number 1. This is what? This is one of the equipotential surface. All right, now we can have, let's say, another distance R1. Okay, for another distance R1, the potential will be what? KQ by R1, right? Isn't it? So I can make another equipotential surface, right or not? Oh, so bad it coming. I can make another equipotential surface. This is one equipotential surface. This is another equipotential surface, right? So we can have a set of equipotential surface. So equipotential surface means what? The same potential. Okay. All right. Now, is the potential of 1 and 2 surface the same? No, because suppose this potential is having the potential of V, then this will be another potential of V1. Okay, but one thing we need to know, where the potential is higher, the potential of V is higher than that of V1. This is quite evident also. R is less means V is larger. So as nearer the surface, nearer the charge, larger the equipotential surface. Further the equipotential surface, the potential value will keep on reducing. Okay, is it clear? So there are some of the properties in the notes I have given to you. These properties are very, very important, which you need to remember. All right, now let's take one by one. All right, suppose I have a charge, let's say mouse test charge. All right, if a test charge is moved in region 1, all right, okay, then what is the work done? All right, now suppose let me call this as point A, point B. Okay, then what is the potential difference? VB minus VA is equal to what? Work done from A to B divided by Q naught. But what is that? The potential between B and A is the same. So how much is the difference? 0. So what is the work done? VAB by Q0 means what? Work done is equal to 0, right? So one of the property is what? The work done whenever on an equipotential surface, if a charge is moved as the potential is the same, work done is how much? 0. All right, fine or not? Like suppose I'm just supposing, suppose in the question it is given this is a equipotential surface, let's say. All right, okay, equipotential surface this is. If 5 coulomb of charge have been moved along the equipotential surface, find the work done. How much is the work done? 0 is the work done. Alright, the same logic will be following. This is property number 1. Number 2. Alright, number 2. Okay, what is the relationship between electric field and potential? E dot dr is equal to what it is? dv, right? Isn't it? Now, on the equipotential surface, how much dv is? 0, right or not? Equipotential surface dv is equal to 0, yes or no? Now, E dot dr is equal to 0 on the equipotential, because the difference between these 2 points, what is the potential difference? 0. What is the potential difference between 0? What is the potential difference? 0. What is the potential? See, we are talking about a particular equipotential surface, right? Now, if it is 0, then, okay, electric field cannot be 0 because the point charge is there, right? Isn't it? So, this dr, what dot means what? Cos, right? Cos of theta is equal to 0. E cannot be 0. Dr cannot be 0 because it has moved. Then something, cos of something is 0. Means what? Theta is equal to how much? 90 degree. What information it gives? Theta equal to 90 means what? Electric field is perpendicular to the surface. Alright, fine. This is very, very important. Point number 2 means what? It says electric field must be perpendicular to what? dr is what? Where the is the equipotential surface along which the charge have been circulated, right? So electric field must be perpendicular to equipotential surface. All right, okay. Now what should be? Suppose in this case, this is an equipotential surface, right? Right or not? Right? Now, what should be the direction of electric field? The electric field must be perpendicular to the surface. Electric field is perpendicular to the equipotential surface. Electric field is perpendicular to the equipotential surface. This will help you. Remember always, equipotential surface, electric field must be perpendicular to the equipotential surface. Okay, so if you are knowing this too, all right, let's say this is uniform field, right? Uniform field. Now what should be the equipotential surface? Then what we have seen, electric field must be perpendicular to the surface. Now this is the direction of electric field. Then how the equipotential surface have to be perpendicular, right? Now perpendicular in a plane will be what? Plates only, right or not? So how the plates will be? This is the one, right? Okay, so these are what? These are the equipotential surface. Now suppose I have a line sheet of charge, okay, the line charge, okay. Now how the electric field is? Electric field will be like this, right? Now electric field will be like this, right? Now equipotential surface, how it need to be? Perpendicular to it, right or not? Now if you join it in 3 dimension, what it is? A cylinder, right or not? Do you understand? Okay, so you have to remember it. Now similarly we can even make for the dipole also. In your syllabus all these things are there. Suppose here is a dipole, Q and Q. Now this is system of charges, right? Now what we know, electric field should be perpendicular to what? To the surface, right? Now make the field lines, okay? Field lines will go from where? Plus to minus, right? Plus to minus, right? Plus to minus, right? Now I can make it plus to minus. You can make it better way, plus to minus. It goes this way and it will enter through this way, right? Now the equipotential surface have to be perpendicular to it. Now add here perpendicular, right? At every point you make perpendicular, make it perpendicular. If you join it, what it will come at this point also. Okay, this is quite complicated, however you will learn it. Okay, electric field is perpendicular to the surface. Okay, so this is the field line. At this point also you make perpendicular. Now you have to make quite dense. Okay, here also perpendicular. Does it look like? You need to, now here also perpendicular. Okay, in your notes you will see. So how the equipotential surface will be circular nearer ends, in the middle it's something like a plane. Okay, so if you remember this thing, you can easily make the equipotential surface of any system of charges. Okay, see the notes for its better understanding. Thank you.